chemistry, mineral is chemistry, water is chemistry, the salt we use is chemistry, sugar we use is chemistry, fabric we use is chemistry. Everything is built up of elements which comes from the atoms and the molecules as well as the structure. Yeah? So chemistry is exotic. It's a start. But inside chemistry, what I'm going to talk to you today is something called the ionic liquids. What are these ionic liquids? Okay. Now, water, that's a liquid. Salt that we use normally for whatever cooking is a solid. When we mix this together, we end up with a solution which is a liquid, right? We all know that. But can we have two solids mixed together to make a liquid? Have you ever watched this before? Like a rock and a rock to make a liquid, for example, right? Well, I'm not going to mix the rocks, but I'm saying it in the two solids together. What we can design is we can make our own ionic liquids. By that way, we can design water ionic liquids, let's say. We have charged species. Can you understand charged species? Like the positive and negative, okay? And then these mix together to give a liquid. The same thing happens in the salt, but it's a mineral, it's a rock, and it melts at 800 degrees Celsius, whereas these ionic liquids, what I'm going to show you quickly, are melting at room temperature. They are formed at room temperature. But they are powerful as a lava. We all know lava, don't we? The one from the volcanic, for example, can dissolve everything. Can dissolve you and me, can dissolve the rock, can dissolve anything in it because it's a fire. It's something like 1,000, 2,000 degrees Celsius. Can we bring the power of that 2,000 degrees Celsius into a liquid at room temperature? 16 degrees or maybe 12 or 8 maybe? Is that possible? Yes, it is. And that's what these ionic liquids are. Let me demonstrate. Fine. That's a very bad picture of lava. We all know how lava looks like. Now, don't worry. It's just a common salt.
Am I supposed to take a video of this?
Yeah, I'm looking at this all.
But not this one, because this is an iron salt. This is sodium chloride, whereas this is iron chloride. Both are solids. Okay? What we can do is I'm just going to mix them together. Solids. They stay as solids. Put some water out if you like. It's a solid. Now, can we get a liquid? That was the question, wasn't it? This is another salt. It's a solid. To start.
You're taking one.
That's what we do. We need white. Otherwise, you mix different chemicals and your property changes, right? This is a salt. As you can see, salt is like that. Now I add the iron chloride.
Yeah, I know everyone's Where have the big cameras gone?
The big one, they were only here to film the keynotes. Who was
While
Aoife
you are
and
waiting
Emma?
for this, you can have a look at that. Do you agree that it is going into a liquid now? Yeah? Where is my beautiful mixture here? Let's shake. I'll keep shaking while I'm talking. It's a bit of sugar, okay? It goes into the liquid. The properties that a lava can do at 8,000 degrees, 2,000 degrees Celsius, the same thing can do at room temperature. It can dissolve everything. How is that going to be helpful? Is it going to be helpful to dissolve something like a rock? How is that going to be helpful? Now, we have water. We need to clean water. The drinking water that we use has different contaminants. Just as an example, we have contaminants, unwanted metals like have adverse effect like in your central nervous system, can make you crazy. We don't need those things. We need to filter them. We need to purify water purification. What we can do is to shake these ionic liquids just like what I shake. That is any clear? Can you see two different layers here? So what we can, well, this is a dyed solution just to make it very visible. So what we can do is to take the ionic liquid, but we design it. We can design it. It's not just one structure. It can have a trillion combination. Believe me, it can have a trillion combination. To shake it, just as an example, to purify water, then it goes separate. The one what is unwanted in your water goes into your ionic liquid and your water is clean. And then you can recycle this ionic liquid for your next extraction. This is the term what I call it as extraction. Okay? And this can be used to recover metals. The one that you're recycling all from the different electronic components, all the scrap metals can be all dissolved because it acts as a lava. It dissolves everything, takes in everything, and then you can coat them back using electrochemistry, for example, to create as a new metal into a different substance. Isn't that wonderful to recycle things like that? Because you can do it at a very mild condition. You don't need a lot amount of energy to go up to high temperatures. You don't need to have fire hazard, experiments. It's very exotic. It's all at mild condition. Now, the dissolution, the taking in process of these liquids are also used for gas phase. You can clean the air. We all know that the greenhouse gases are important to keep the temperature, to keep us going with all the protection from the UV radiations and stuff like that. But the carbon dioxide, which is one of the greenhouse gases, is going up because of human energy expenditure. So even the gases can be dissolved in the liquids. Fine. What these ionic liquids are good because they don't catch fire like some other substances. They are mild. Let me show you a quick experiment. We all know nail polish remover, for example, is a solvent. Yes, this is acetone, which is commonly used in various, processes. So as you can imagine, this catches fire. As you see in all your products, in all your solvent-containing spray and everything, you will see the word flammable, right? That is my secret lighter. Lighter. Can I use that lighter? Here we are. With this temperature, maybe this won't catch fire. Right. I hope you can see the fire, yeah? Now, definitely on fire. Which catches fire? Well, I stopped it because there is no oxygen now, therefore the fire stops. But, where is my beautiful ionic liquid? There we are. This is an ionic liquid. As you see, it looks like a lava. But it's not a lava. And let's see if it catches fire. It would be nice to have a burning torch for example. No fire? You agree with fire because you can hold it on fire for any longer you want. It won't catch fire. It's not inflammable. Isn't that wonderful? The other best application of this is in energy, in batteries. We need batteries for all our phones. That's how it's our batteries rather than a charge for long. Right? Is that a very basic understanding? Why? There are six reasons. We can have water solution in the batteries. We can have the flammable solvents that I showed you in the batteries as well. Therefore, some batteries are not even allowed to be transported in the air because there can be an explosion up in the air. Even with the Malaysian Airlines, which was missing, there was a myth that there were lithium batteries transported. You might have read in the stories due to catching a fire inside the lithium. There are different reasons to make this catch fire. Now, if we can have the ionic liquids in the batteries, they hold the charge longer because they don't evaporate, they don't catch fire, so they are very environmentally friendly and they can live longer. If you can imagine that it won't evaporate, so therefore the life goes longer. Yeah? Now, just to demonstrate that they are powerful, we have salt, back again to sodium chloride. This is a commonly used electrolyte for a battery.
Spreading the viruses around.
Now, we have here, this is the normal multimeter. This is a normal cell. One is a cathode, one is a anode. If we have this as an electrolyte, if you look at the meter reading, then you read the number in the virus. Sorry, what number is that? What's it? Right. It's on the wrong number. Sorry. There. Sorry, it was reading not the voltage, but it was reading a different number. Okay, so that's 290. Okay, so that kind of number when you have a normal salt solution. So, why? Because we don't have this contamination. I have an ionic liquid there, not the water this time. And then we have the same battery electrodes.
Thank you very much. Okay. 330.
Well, it's a higher number. Just for like kitchen experiment, okay? If it is done in a nice way, what I'm trying to demonstrate is the power that you get from the ionic liquids or almost the double that you get normally from an okay? So, the other application of these exciting materials have also gone into pharmaceutical application. The tablets that we consume are solid. Yes, I know children have nice fluids, but the fluids, how they are made is to dissolve the solids in unwanted. Okay? But if this same pharmaceutical component can be made as a liquid, then it is easily to consume. You can apply transdermal, can permeate through your skin nicely and attack your target and help you for curing curing your problem. So if the same pharmaceutical things can be done as a liquid, that's an advantage for consuming. Yeah, it also is easy when you swallow. For example, why do you think we have a liquid for children? Not only because it is tasty, it easily goes towards the various, the biochemical processes are done very quickly because it's in the liquid form. So if the pharmaceutical things are in the liquid form, their reactivity inside your body functions can be improved as well. So these exciting materials, which is some group of chemicals which can be applied for energy, which can be applied for cleaning, which can be applied for plating like electroplating and various other applications including pharmaceuticals. I welcome you to enjoy this nice research in future, and I hope there will be a day where there will be only ionic liquids and not solvents and no flammability. Yeah? Thank you very much.